Alright, this video focuses on adding and subtracting square roots. In order to add or subtract square roots, you must have like radicals. What does that mean? To be like radicals is you must have the same index. So here's a square root plus another square root. The index must be the same. So this number here and this number here must be the same. So for a quick example, you don't need to write this down. Let's say we have the square root of 5 plus the square root of 3. You can combine them together as 5 plus 3, which is 8, and then reduce that down. All right, let's go ahead and look at this example here. So we have 7 square roots of 11 plus 6 square roots of 11. They're considered alike. They have both a square root of 11 as their like radical. So what you do is you take the coefficients out in front. So the 7 and the 6 are going to be your operations, so 7 plus 6. So we say the radical then comes along for the ride. So 7 plus 6 is 13, and then square roots of 11. All right, here's some more examples. So we have 7 square roots of 2 plus 5 square roots of 2. First check, are these considered like radicals? Yes. Square root of 2, square root of 2. So what's out in front are your coefficients, 7 and 5. The operation between them is an addition symbol. So 7 plus 5 is out in front. The square root of 2 goes to the back side. So 7 plus 5 is 12, and then square roots of 2. All right, second example. The square root of 5x minus the square root of 7x. Check to make sure they're alike. Yep, they are. We have the square root of 5x, the square root of 5x. So we go out in front. I'm going to go ahead and put a number 1 here. So you see that it's 1 square roots of 5x. So the coefficient is 1, operation is a minus, and then 7. So out in front we have 1 minus 7, and then the square root of 5x. So 1 minus 7 in the parentheses reduces to negative 6, and then square root of 5x. A couple more examples here. Sometimes you look at the radicals like example A, square root of 3 and square root of 12 are not considered alike. But sometimes if you reduce a radical or radicals down, they will become alike. So let's go ahead and reduce square root of 12. So I'm going to leave the 7 square roots of 3 alone. Now we need to break down or simplify square root of 12. The square root of 12 can be rewritten as 4 and 3. 4 times 3 is 12. Now we have a perfect. Square root of 4 is 2. The 3 is going to stay underneath. It doesn't have a pair. All right, now the first radical, we're not touching that at all, so that's still just 7 square roots of 3. Now look at these two radicals. Are they considered alike? Yes, so we have square root of 3 and a square root of 3. So our coefficients are 7 plus 2. So 7 plus 2 is out in front. The radical is square root of 3. So 7 plus 2 is 9. Square roots of 3. All right, next example. The radicals do not look alike right now, so we need to reduce them down. So we're going to go ahead and break down 50. 50 is 25 times 2, and we still have the x. All right, now 25 is a perfect. 5 times 5 is 25. So 5 is going to pop out. Square root of 25 is 5. The 2 and the x are not a pair, so they're going to stay underneath. All right, now we have 4 times 5. 4 times 5 is 20. Square root of 2x. All right, so we've just simplified this first radical. Now, since change colors, let's go on to the second radical and break it down. So I have minus 6. I'm going to break down 32x. So I'm looking for a pair or a perfect. So I'm going to say 16 times 2 is 32. And then I have x. 16 is a perfect with 4. 4 times 4 is 16. So 4 is going to pop up because the square root of 16 is 4. Now what's underneath is this 2x. Now I'll simplify. Negative 6 times 4 is negative 24, and then square root of 2x. All right. Now let's look at these two radicals. They are alike. They both are the square root of 2x. So the coefficients are 20 minus 24. 20 minus 24. The radical goes to the end, square root of 2x. Now 20 minus 24 is negative 4, square root of 2x. That's how you add and subtract radicals.